Hi, my name is Tyrone Wilson, and today I'll be presenting an interactive sportsbook demo which has been built to illustrate some of the enterprise-grade features provided by the Kaazing gateway. Advances in web messaging technology have allowed gaming companies to grow and expand the service they provide to their customers. They all strive for the same thing: maintaining their customer base, finding ways of attracting new customers, having an architecture that can scale and provide opportunity to branch out into new territories or regions. But ultimately it's about providing a service that leads to an increase in company revenues and market share. This video provides an insight into how Kaazing can help your company grow, be more competitive in an industry where technology and consumer demand is ever changing, and become a market leader by helping you build the next generation of web and mobile gaming applications. Let's turn our attention to the demo, and as I go through it I will highlight some of the features provided by the Kaazing gateway. Let me log into my gaming application using the login screen you see before you. In the client UI, I am going to subscribe to the market information I am interested in this case the English Premiership. From here I can view all the available events and relative selections in that market. As the data has been received from the data source, the main table is dynamically created and populated with rows of information relating to specific events or matches. You will also notice the updates being applied as and when they are published from the back-end service. So the first feature I'm going to illustrate is known as Last Value Cache. Last Value Cache, or LVC for short, is an inbuilt configurable memory cache within Kaazing Gateway that maintains the most recent value, up-to-date value, for every piece of information published to web and mobile clients. The purpose of this memory cache is to provide the client with an initial snapshot of all the data they are interested in. When I subscribed to the English Premiership, LVC provided the initial snapshot for every event and selection before it allowed the client to join the mainstream of live updating data. LVC is configurable, therefore you can decide how or what information needs to be provided to the client before they start receiving updates. Let's see what happens when I request information for items of data that do not have LVC configured. The gateway does not have LVC configured for County Cricket, so when I subscribe to County Cricket, watch to see what happens in the main table. You can see the table is being created, as you would expect, but it has not received the initial snapshot of data from LVC. It is building the table dynamically, as and when it receives a full record from the back-end data source. This is why it's taking longer to build the table. The Kaazing gateway provides a powerful tool in LVC. If you can imagine a live environment where the client UI is receiving data from multiple data sources, as a user you would not expect to see empty data fields or missing table rows where the information has not been published. By using LVC, you can provide a consistent user experience where the user first receives a snapshot of data up to date at the time they make that subscription, and they then join the live stream of data for any further real-time updates. Back to the demo, I'm going to subscribe to the English Premiership market again, mainly because it's my main sport. Notice how quickly the table is created and populated, providing further evidence to the power of LVC. I'm going to place 2 bets, and you can see the bet records in the bet slip table in the top right hand corner. When I submit the bet slip, watch to see what happens. The bet slip information has been sent to the back-end business service where it can be processed. On completion, the service will generate a notification message to be delivered back to the client. As you can see, the bet slip information has now been removed and there is a bet record in the bet history table. Let's do this again, but with a more adventurous bet, perhaps a 5-bet accumulator. I click the submit button and see what happens to the bet history table. As you'd expect, the bet history table now has 2 bet records and the bet slip table is empty once again. Although this is very impressive, what I'm really demonstrating here is the power of WebSocket technology and the ability to communicate bidirectionally between the client UI and the back-end business service. Although I'm receiving updates for pricing information on the initial WebSocket connection created when I first logged into the application, I am also able to send messages from the client UI to a back-end business service using the same WebSocket connection. You will also notice there are no latency issues or reduction in performance. The user experience remains constant, even though there is more demand being placed on the network and the connection itself. I'm now going to open an administration UI and use the functionality provided to demonstrate more of the Kaazing Gateway features. Once again, I'm going to request information or subscribe to English Premiership, and you'll see that the main table is created immediately. As an administrator, I've decided that I will make changes to the events that are currently available to my clients. I've decided to suspend 2 of the events that are currently in play. You will see that as I'm selecting these 2 matches from the suspend table, the main table is being updated with suspended messages. If I navigate to my client UI, have a look at the main table here. The events have been suspended and I'm no longer able to place a bet on these events. Again, this is demonstrating bidirectional communication. I am sending a suspension message to the back-end service using the same WebSocket connection. It is applying some business logic to that information and then publishing suspended messages to the clients who have subscribed to those events, thus preventing any further user interaction. I can also reverse my decision and reinstate these 2 events by selecting them from the revert table, sending revert messages to the back-end business service, applying reintroduction business logic to these events, and then publishing first a reintro message and then an update for the latest available price from the back-end data source. It is not using LVC in this instance as the application business logic dictates the updating price must come from the data source, not the latest value from LVC. The next feature I would like to demonstrate is all about the power of the Kaazing client libraries and their ability to handle huge demand, a high throughput of messages to the client UI. I can demonstrate this by manipulating the number of messages generated by the back-end data source. The current configuration is set to 600 messages per second. While I'm demonstrating this, please keep an eye on the bandwidth values in the profile stats table. It will change dramatically as I manipulate this frequency. You will also see a change in the main table, the frequency by which the updates are being applied. If I increase it to 5,000 messages per second, you will notice how the prices are updating more frequently, but you will also see an increase in the bandwidth usage. This is obviously because there is more information being delivered over the wire. Let me increase the frequency even further to 10,000 messages per second. See how that changes the updates to the main table and the bandwidth statistics. Now let me show you the client UI and you will see the same update frequency being applied here. Although this is not a realistic representation of a live environment, you would never have a situation where that many updates are being published to subscribed events in a client. But it does provide you with an idea of how well the Kaazing client libraries can handle this surge in demand and increase in activity. The user experience ultimately remains constant. There are no delays, but more importantly, there's no loss of data. So the final feature I'd like to demonstrate today is known as delta messaging. Delta messaging is also configurable within the Kaazing gateway, and it provides a mechanism by which you can reduce the size of the message being delivered over the wire. This type of optimization contributes to the reduction in bandwidth utilization and network costs. Currently, my admin user is subscribing to the English Premiership market and is viewing all the available events for that market. The content of each message published from the Kaazing gateway includes a reference to the event, Aston Villa vs Liverpool, a reference to the selection type, home, draw or away, and finally the actual price value. As you can see from the profile stats table, the size of each message and the bandwidth usage figures are fairly high. But if I configure delta messaging for this subscription, watch to see the effect it has on those statistics. As you can see, the values in message size have reduced significantly, but the big eye-opener is the reduction in bandwidth. It is now almost a quarter of what it was before. So you can now see what a difference delta messaging can have to your gaming application. If you add this to the binary encoding that is already applied to each and every message published from Kaazing Gateway, you will soon see the advantages these features provide: network efficiency, cost reduction, and an enhanced, consistent user experience with no delays, no reduction in performance, and no loss of data. That now concludes my video demonstration of an online sportsbook web application. I hope you have enjoyed it and found it to be useful and informative. If you need any further information or you would like to discuss the demo or the Kaazing Gateway, here are my contact details, and I look forward to speaking to you in the near future. Thank you for your time today. Goodbye.